So DFINITY is a not-for-profit foundation that is building a protocol called ICP, Internet Computer Protocol. So we're extending the internet with serverless cloud functionality. The way to understand it is today there's a protocol called TCP/IP, a decentralized protocol that connects independent internet service providers, transit providers, corporate networks, and so on to create the public connectivity service that we know today.
Most people don't understand how this works, but it's literally how you go into google.com, type a browser link, and it comes to you. That takes a lot of stuff in the background.
Sure,
which is
it's a protocol. So, if you and I were communicating on WhatsApp, the packets of information would be flowing over multiple proprietary infrastructures. But we wouldn't know anything about those proprietary infrastructures. We're just interacting with a protocol, the internet protocol. So today, the internet only does connectivity. You have low-level connectivity, you have high-level connectivity like HTTP, which connects structured content like web pages. But if you want to create a business system or an internet service, you need proprietary infrastructure. Either you need your own servers or you're going to buy packaged servers from someone like Amazon Web Services or Google Cloud. Internet Computer Protocol is an internet extension that combines independent data centers to create a serverless cloud, or rather provide serverless cloud functionality. So that means that you can build systems, business systems, internet services, and host them on the internet itself, rather than on a proprietary closed cloud like AWS.
That's a lot. I mean, so basically what you're saying is that you could essentially replace AWS one day, or replace Google Cloud.
Yeah, it's actually more than that. So the internet computer is built using a lot of advanced computer science. It capitalizes on changes in the landscape. So, the price of hardware, for example, has fallen dramatically over time. So now it's practical to replicate data to a much higher degree. The price of CPUs has fallen, so now you can run more computation, things like cryptography. And of course the internet's far faster. So you combine that with a lot of new advanced computer science, some of it that's been under development for decades, and not only does this, the combination of these things make the internet computer possible, but it enables us to really reimagine what software is. So the internet computer is an alternative technology stack. So today's technology stack is, according to Gartner, worth just shy of $4 trillion. And it includes everything. It's the cloud providers, the database providers, the whole thing. And the internet computer is actually a completely new framework for building software. So because the serverless cloud functionality is provided by a protocol, the properties are very different. So for example, clearly it's a decentralized protocol that has to succeed in a public environment, so it's secure because of mathematics. In the same way that Bitcoin is secure because of the underlying protocol.
So blockchain is the underlying technology that you're using, or no?
Kind of. An evolution of blockchain and a lot of advanced cryptography. What it provides is a tamper-proof platform. You cannot hack the internet computer. So the difference is today, if you're a corporation, for example, you have this hugely complex IT infrastructure. Behind the scenes, there's databases, middleware servers, web servers. You have all these people working on it. If you misconfigure just one of these components, or if any of the people working for you misconfigure any of these components,
or it's hacked.
You get hacked.
Yeah.
Yeah. A hacker's going to get past your firewall, put a rat on your system, and he has pretty much total control. Most companies who think they're secure aren't. It's just because they're not important enough for a hacker to bother hacking. Right?
Yeah.
And so there's this huge problem with security. The internet computer is hack-proof, and sans egregious errors, you can build hack-proof systems on top. We think that's a major advance. It also massively simplifies the software development model to bring down costs, reduce your time to market. The third interesting dimension of the internet computer, which I think will prove to be huge, is that it supports a new kind of software called autonomous software. And autonomous software doesn't need a human owner or an organization running it. It updates itself and evolves using a governance system, and you can use it to create open versions of internet services. And the advantage is that
so a self-running Facebook potentially, or
potentially,
something.
That's right. Let's take something simple like LinkedIn. LinkedIn started off saying, look, put your business profiles into our service. Everybody will be able to access it via the programmable web. They have all these APIs, or they did have all these APIs. And a couple of years ago, they just revoked the APIs for hundreds of startups. The knock-on effects affected tens of thousands of companies.
Or Twitter with its APIs.
Same thing,
yeah.
Twitter, Facebook, they've all done the same thing. And in the end, only the big tech was left with the API access, like Salesforce or Microsoft. And the example, a clear example of what this can do to you is Zynga. Zynga built on Facebook.
The gaming company. Yeah.
It was doing fantastically well. Was valued north of $10 billion, IPO'd. Facebook changed the rules. And
Farmville was gone.
A few weeks later, it was worth, a tenth of that. So that tells you what platform risk, that tells you what building on big tech can do to you. And the problem today is that, it's very difficult to create extensions to the internet, the internet ecosystem that don't involve data that's coming from big tech. But it's also very difficult to get funding for those kinds of extensions because, at the end of the day, if you're building on big tech, what have you got? Do you own your own system? If you're succeeding, they might try and do it themselves and revoke your API. If you're competitive, they'll certainly revoke your API. So open internet services will provide a means to solve this problem.